Hi, everyone. Welcome to our webinar, Investigating the Chemistry of Food Dyes and Sports Drinks. I'm going to go through a few housekeeping items while people are joining us. One, we appreciate you taking your time out of your day to attend live. We'd love to answer your questions throughout the session. We have Melissa and Noose who will be presenting the workshop, and we'd love to answer your questions. Feel free to use the chat or the Q&A. We'll be monitoring both of those, and you can also use the raise your hand icon on Zoom as well. We'll do our best to answer everyone's questions, but if we happen to not get to yours, we will get back to you after today's session. In a few moments, I'm going to share a link to a shared Google folder that has additional resources that have been put together for today's webinar, and you'll have access to that. We're also recording today's session, and I will also put the link to where you can find that recording on our website in the near future. And just to let everyone know, you will be getting a follow-up email that includes links to the webinar recording and the shared Google folder with additional resources and also a certificate of attendance. So with that, I will pass it on to Noose and Melissa.
Hi, folks. My name is Noose Hisim. I'm a chemistry specialist at Vernier. I taught chemistry in Maryland for 34 years, and I've been using Vernier equipment for 31 of those 34 years, and came to Oregon in 2016 to work at the office here near Portland. And let me see, let me get up here. I know we had some kind of screen set up. Here we go. Melissa, you want to tell them about yourself?
Sure, yeah. Hi, everyone. I'm here to help Noose out and answer all your questions. I'm one of the chemistry staff scientists here at Vernier. There's only 3 chemists, me, Noose, and Elaine. So if you call with questions about chemistry, you're going to get one of us. I've been working at Vernier for 11 years this month, actually. So I do a lot of these types of trainings. I work with curriculum development, software development, and actually my favorite thing to do is our product development. So there's we wear lots of hats here. It's a pretty small company, so it's pretty fun to get to do lots of different stuff. And yeah, I used to teach at the college level before I started at Vernier. So you'll find all of us in tech support have previous teaching experience, and that helps us kind of design stuff and see it from your perspective a little bit better.
So this is my stuff, but I just told you about that. So let's move on. So I taught AP Chem for 25 years, and I read exams in 2011 at Daytona. Well, of course I won't ever do it again, but even after that first time, it was a great PD. So I highly recommend anyone who's a chemistry, an AP Chem teacher, if you can read and you have the opportunity to do it, I would highly recommend it. But I wouldn't recommend it as a continuing thing personally, but some people love it. They go back every year. The big thing that I got from reading was understanding what students were being presented with during the exam, well, at least the pre-response, and how they responded, because I actually got to read 4 different questions. I read 4,000 questions over the course of the week that I was there, but different ones. So I did equilibrium, I did electrochem, I did the precipitation experiment. And so at Vernier, what we have is we have a lab manual that was written by Jack, and I think Melissa had some input in that, and Elaine, to kind of parallel the College Board 16 experiments that they recommend. This one's super popular. I've been doing APSIs for this one all summer long, and I thought, gee, it would be kind of neat to share with folks. And so that's the plan, is we're going to look at experiment number 1, the sports drink experiment, but it also has a Beer's Law component to it. So if you don't teach AP, it still could be useful to you. What I'm going to do today is we're going to do 2 roles. Role number 1 is going to be teacher setup. How do you prep for this thing? And you're going to see how easy it is. It's super easy, and I have some tools for you to make it even easier. Then we're going to do something a little different than the last couple times we did some webinars. We're going to use a Labquest 3. Now, this experiment could be done with a Labquest 2. And so and you'll see, some pictures of that. But Labquest 3 is what we're selling now, so we wanted to kind of do that. This thing could be done. This experiment could be done on with a piece of free software we have called Spectral Analysis. It could be done with the Labquest. It could be done with Logger Pro. I mean, there's various ways that you could do this experiment. So don't feel like the way I do it is the only way that it can be done. That's absolutely not true. It could even be done with a colorimeter, but College Board kind of wants the kids to see full spectrums, and so that's why the spectrum is preferable. But I do have a folder in the shared folder for how you could do this even with a colorimeter. So that's not impossible. The other thing we're going to do is we're going to highlight a little bit our remote data sharing ability through our software, Graphical Analysis. So if you don't have that installed on your device, I would suggest put it on something other than what you're watching the webinar on, so that you can kind of play along and see what's going on. So you could put spectral analysis, pardon me, I said that wrong. You could put graphical analysis on your phone or on a Chromebook or something that's a little bit a different device. That way you don't have to keep flopping screens. And then we'll talk a little bit about expectations and questions, and just raise your hand or send us a chat or whatever, so you can get our attention. Listen, Angie, I don't tend to pay attention to the chat box. That's because I get distracted by the webinar. So
and that's what we're here for.
Exactly. And don't be surprised if Melissa jumps in and says, "Hey, Deuce, you forgot to save the thing." This whole slide deck you're going to get. It's in the shared folder, and Angie or Melissa will put the link to the shared folder. So if you want to peek in there and see what's in there, you're welcome to do it. This other link will take you to Graphical Analysis, so you can install it if you need to. It'll run on anything. That's the beauty of it. If you want to put it on your phone, go to the store for your phone to get the app and put it on there, and we'll make it pro. We're going to give you pro option ability today that'll last couple of weeks. I think it's a 10-day license that we're going to give you, but you can fiddle with it after the session. So that's kind of the plan. The other thing that's in here is, with what you all just went through, Vernier was mostly in a supporting role with the pandemic, but so many of you were at home, and it's like, how do I do something authentic with my students? And so we have a number of options for remote education, and I put all the links on here so that if you want to explore it later after the webinar, everything is there that you can look at. Pro, we're going to do today, so you're going to have an intimate knowledge of that if you install Graphical Analysis on your device. But we have some remote data available, and there's some other things, so you may want to explore that and see if there's anything there that might still be useful. You might have students at home that are sick, or maybe, who knows what's going to happen in the next few months with some of the raging Delta virus stuff. So Delta strain. So, we don't know. So it might be nice to have some of these things in your back pocket. Here is the whole point of today. College Board came out with a lab manual of 16 experiments, and they said you should do 6 of them from this book at least. Inquiry based. And so what Jack did is he basically paralleled it and said, we have a lab manual that wherever it makes sense, let's make a Vernier sensor available for teachers. So it's really very close. And so, here is the data analysis part. And you can see that how ours kind of parallels it. And so if you want to use your Vernier sensors to do College Board labs, then this lab manual might be the solution for you. Vernier lab manuals, the cost of them is kind of, we get a lot of questions about it. You buy one copy and it's a site license for your school. So you can make as many copies of it as you want. We provide you with directions for Labquest. We provide you with directions for, in this case, you can see it's spectral analysis. So we have different ways that you can collect data, and you get all that in electronic format for the cost of just one copy of the lab manual. So it's a really good deal as far as that goes. This is my setup that I'm going to use today, and I actually have a camera set up so you guys can see, you know, live. Of course, there's my lab station. Here I am, and so we'll do that here in a minute. But you know, this is the setup, you know, to use the Labquest 3 and the Go Direct Plus spectrophotometer. But what if you don't have those things? You know, what if you have an older SpectraViz and a Labquest 2? Hey, guess what? You can do this exact same experiment almost exactly the way I'm going to do it today. So don't feel left out, you know, and by all means, shoot Melissa a message if you're curious, you know, well, can I do this with an original Labquest? Some things you can actually, so we can talk about that. It can also be done, like I said, with colorimeter. It's just, I'm not going to demo that here, but I did put some files for you. So let's do this first before we get to this. Let me show you the teacher side of things. Okay, let me get my camera up here. So you need to prepare the solution for your class. How do you do that? And so let me show you something that I put in the shared folder that could be really handy for you to use. Let me bring that up here. This spreadsheet is in the shared folder. And the idea here is that the day before or whenever, you need to set up your standard solution so students can use that to measure the transmittance, create a curve, you know, a graph. It won't be linear with percent transmittance, but you know, the idea is that they should, you know, they're the way the College Board lab works and the way ours works, if you're not familiar with it, is the students first determine a relationship between transmittance and absorbance. And then they determine the concentration of the solution based on their standard curve. You know, some people call it Beer's law. It's Beer's law if you're looking at absorbance usually, but it's just a standard curve. I used to do sugar solutions and things like that when I first started. This spreadsheet, I also put something at the bottom here to help customers understand why we recommend that the absorbance values be between 0.1 and 1. And if you look at this graph later, you'll see that the relationship between percent transmittance, how much light gets it through the solution, and relative absorbance, how much light is absorbed by the solution. The part of that we would like you to do your experimentation is falls in this curvy part here. This is it's a logarithmic relationship, spoiler alert. And so if your absorbance is over 1, notice how flat this is. Remember that every decade you know, is a factor of 10, right? And so when you go from 1 to 2, you are actually multiplying by a factor of 10 because this is a logarithmic, a base 10 log relationship. And so you don't get much change in absorbance when you get over 1, and the same thing happens below 0.1. It kind of flattens out. And so if you want to stare at this later or think about it, that's why I put that in there. But this is the part we need. Here's the plan. I want to do this lab tomorrow or next week, and I need to prepare a stock solution for my students. How do I do it? Okay, so let me show you. Now, I'm going to use a Labquest, but nothing says you have to do that. You could use spectral analysis, you could use Logger Pro, it could all be done the same way. So I've got my SpectraViz plugged into the USB port on my Labquest, and what I need to do is create my stock solution. So here's one that I made, you know, for other purposes, you know, some time ago. And so roughly 1 drop of food dye per 200 milliliters of water usually works pretty well. So I've got 200 milliliters of water in the beaker there. I'm going to put 1 drop. Let's see how close that works out. So with all of our spectrometers, and if you've used a Spec 20, it's kind of the same idea. You need to calibrate it. I've had this guy plugged in for some time today, and so what I'm doing is I'm rinsing a cuvette. Our spectrophotometers come with 15 plastic. Well, this one does. It comes with 15 plastic cuvettes, and so I'm going to calibrate it. And so my solution is going to be in water. I did a webinar last night. Yeah, it was really late. And I extracted chlorophyll with alcohol, with isopropyl alcohol. So then I used alcohol as my blank. But in this case, I'm going to use water. And then if you look at the cuvettes, you'll notice that there's two sides that are clear and two sides that are fluted. I mean, the fluted sides would be the ones that you might hold. The clear sides, you want them to obviously be clean. And then if you look at the spectrum is the light path is left to right that we're interested in right now. And so we're going to want to put your cuvette in so that the light passes through the clear sides. And then we're going to calibrate the spectrum is. So a couple of ways. If I press collect, it usually puts you in the calibrate mode. You can also just tap on the meter and do that. And so it's going to come up and it's going to, it's turned everything off. This is the 0% T if you were the old Spec 20 user. Now this spectrum has been plugged in for a long time. I set everything up a while ago because I'm kind of a little OCD when it comes to that. So you'll notice, and if on this, you can't really see it quite so well because of glare here, but if you look at my screen, you can see it says skip warm up. And so if you've been using your spectrometers over the course of the day, you don't have to go through the whole warm up process. The very first time you do it, highly recommend that you let it go through the whole warm up process. So the cuvette is in, and so I'm going to tap finish calibration. And so I'm going to get my my baseline. Okay, so it should pop up here and say that it's done. There it is. So it's ready. Okay, so I'll get that out of there. Now let's check my solution. Okay, because we want that stock solution to have an absorbance between 0.1 and 1, and ideally something between like 0.9 and 1 would be really good. So let me grab some of that. And I'll rinse my cuvette with a sample here since I've got a lot. You might have to think about like how much you need. If you go back and look at the experiment, students are going to be making some dilutions. I'm going to do some here in a bit too. And you might have, I did 200 because I don't really need a ton for this workshop, but you might need to make a liter or something like that. And so let's look at the absorbance of my stock solution. Remember, I want the absorbance to be somewhere between 0.9 and 1. Let me take a look here. And if I look at the graph, each division is half. And so I've got, this would be, where I'm pointing at here would be, that would be 0.5. This is going to be 1.0. And then the top here is 1.5. So it's a little strong. So I'm going to go ahead and dilute it a little bit. And let's see if we can get it down, below 1. Would be ideal. So I haven't stopped collecting data, so it's just going to keep doing that until I tell it to stop. So let me grab a fresh sample here. Since I'm using the same barrel pipette, I'll rinse it, and I'll do the same thing with the cuvette. Ideally, good spectroscopy hygiene, you use one cuvette for everything. Sometimes practicality, is important in terms of time. So people will, they'll use one for the water and one for these solutions. But ideally, you should use the same one. Optics and that kind of. Ooh, I'm close. It's a hair bit over 1. So I'm just going to add just a dash of water to my solution here. Okay. But yeah, that's pretty darn close. So now, when you're doing this the day before or the week before or something like that, I mean, you can set these up far in advance, but with evaporation, you might have to read your absorbance and make sure that it's, you know, hasn't changed if you're planning on storing this for a long period of time. But it's still pretty easy. So here's my sample that I hope is going to be the one we're going to use for the rest of the experiment. So let it kind of catch up there. Oh, I like that. Okay, so I'm going to stop collecting data. And the most important thing I need to know now is I need to know that the absorbance of that sample. So on the Labquest, you tap on the screen, and these little doodads at the bottom here, they let you kind of jump around so that you can find that maximum value. On all our software, there's some way to do that. This reading in the top right corner is the reading of that peak. If I wanted to, I could go do a statistics analysis and it would give me the max value. So yeah, 0.93. So that's what I need for the spreadsheet. Let's go back to the spreadsheet. So I put, last time I did this, I got 0.993. That was kind of amazing. But anyway, still, this is pretty good. This falls within the realm. So what I've done here, and this little spoiler alert, is I wrote the spreadsheet to basically solve the Beer's law expression, there it is, for concentration. So there is the concentration of my stock solution. So what you would do is you would take this stock solution once you've got the right reading, get a bottle and set up a bottle and label it, and you would, on the bottle, you would put this concentration, 7.15 times 10 to the minus 6 molar, and that's for blue. Nothing says that you couldn't do other colors, right? You mean one lab group could do blue, another lab group could do red. You know, you can do, on the spreadsheet, I put all different molar absorptivity constants for different dyes. I got these from Thermo Fisher, so pretty confident that these values are reasonably good. So if you wanted to use like a red, the red one, you just got to be careful. There's two reds, so you need to read on there which one it is. And, for the store red is number 40, and that's probably what's in there too. But you'd have to adjust the spreadsheet a little bit because it's taking the value from here and it's calculating that. But now I'm done. The teacher part is done. Okay. And so now what I need to do is I need to switch over to student, and that's where you guys get to play too. Okay. So here's what we're going to do. I'm going to readjust my screen here a little bit so you guys can see what I'm doing. It's the next day, and your student walks in and they plug their SpectroViz in and they get a screen that looks like that. Okay. And if they follow the instructions on our experiment, it'll say to change that to %T. So if you tap on a Labquest, if you tap on the meter window, it says mode, and you can change it to %transmittance. Okay. And that's pretty much ready for, this is what it's in the instructions in the lab, and I put the instructions in the shared folder. So you guys will have all this. You don't need to frantically write anything down or whatever. But wouldn't it be nice, this is kind of a rhetorical question, wouldn't it be nice if you guys could get the data while I put it in? Okay, I think that would be kind of a nice thing. So what we're going to do is we're going to do that right now. So if you have a device that has graphical analysis on it, this is my iPad. Okay. And it's not already you don't already have Graphical Analysis Pro. When you launch Graphical Analysis, you're going to get, this first screen is going to have a box down here that's empty. And you can see this is my iPad has that box, and my computer I'm using right now has that box. When you buy Graphical Analysis from Vernier, it's an extra charge. There's a free version, which all of us are using right now. But if you want to take advantage of something like this remote sharing that I'm about to do with you, you need to buy, you have to buy the Pro version. Now it kind of follows the same, at least some of the same mentality that our books do. You buy one license for your whole school. Okay, and so for us today, I got a temp license. It's right, where is it, Melissa? I know I put it in here somewhere. There it is, okay? And so did you want me to paste that in, or can you grab that? I can paste it.
I'll grab it. No worries.
Okay.
You keep going.
Okay. So here's what I need you to do with me. If you want to play along so you're not just, getting bleary-eyed during the workshop, what you need to do is put that code, the number 0, lowercase ndlx, the number 8, capital W, capital N, lower r, put that into your device in this box. So, on my nice thing is on my computer, whoops, I think Melissa put that in the chat, didn't you? Yeah, there it is. I'm going to go grab it from the chat, and on my computer, I'm going to go ahead and paste it in. Can't really do that as easily on my, why it's not pasting in for some reason. Oh, something whacked out here. I've lost the ability to type. Oh, there it goes. Okay, maybe it will paste. There it goes. On my iPad, I'm gonna have to put it in, but let's do that so that you guys, this should look just like, or at least similar to what you guys are doing. And so let me put it in there. 0. Where'd that thing run off to? NDL. Now, the neat thing about this is you only have to do it once. So your students would only have to do it once too. So once it's done, if you do it right, you should get a little notice that your copy of Graphical Analysis has been turned into Pro, and it tells you when the license expires. If you buy a license for your school, they go all the way to the end of June of the next year, so all the way to the end of June 2022. And like I said, you do this on every device, so your teacher devices, your student devices, you do it on all of them. Okay, same code applies to all of them. So what I'm going to do now is let me bring up. We're back to doing the lab. Okay. It's like, oh, okay, that's cool. Yeah, let's do the lab. All right, so what do your students need to do? Okay, well, they need to first they need to decide what lambda max is. That's like step number 1 anytime you do a spectroscopy type experiment. And so what I'm going to do is I'm going to do a little bit of finagling here on my end. I'm going to connect my Labquest to my copy of Graphical Analysis. Don't do this part, just watch, because you won't be able to. This requires my Labquest be on my local Wi-Fi network, and you obviously aren't on my Wi-Fi network. I'm going to go to File, New, and I'm going to choose Data Sharing. And I'm going to connect to my Labquest. So this, where it says local, my Labquest, I have 2 Labquests in here. This is a Labquest 3, so I connect to it. And you might notice, let me zoom this up. In Graphical Analysis, when you're doing presentations, or maybe you just are old like me, you can magnify the screen a little bit. It's under the 3 dots in the top right corner under Presentation. There's a little magnifying dude. And so you'll notice that mine says %T and wavelength. And if you look on my Labquest, it's kind of similar. It's pulling the data from the Labquest. Now, you get to go ahead, Melissa.
I was just going to interject and say this would be really, really useful if I have, one Labquest for a group of like 5 students all gathered around a Labquest. Instead of them staring at the little tiny screen of the Labquest, each of them just pulls out their phone and downloads the free Graphical Analysis or the GA Pro code that we just gave you, and then they're able to watch in live time what the Labquest group is doing. So that's what I see this as being really, really helpful for with kids, is they can all have the data in real time that are all standing around the Labquest. So sorry to interrupt, but I'm just that's so good. Cool, because it's like this is the local sharing. So
this and catch that last phrase that Melissa just said, local sharing. You'd have to be in the same Wi-Fi network as the Labquest in order to do this. But you guys aren't. You guys are, who knows, all over the world. And so wouldn't it be nice, you might have just figured out that I like to ask these silly rhetorical questions. Wouldn't it be nice if I could share my data with you? So I'm the teacher, you're the student. So what I need you to do is I need you to go to the file menu, the thing that looks like a little, it says untitled right now, a little piece of paper. And I need you to do, if you're not already on this screen, put yourself on this screen and tap on data sharing. And then I just need you to wait for a second. Okay, so here's my, let me get my iPad back over here so that you can see this. So the iPad would be you. So you would be just pick data sharing and then just wait, because I'm going to give you this code right now. Okay, so I'm the teacher and I want to share this experiment through the internet with whoever, you know. And so what you do is, as the teacher, you tap on this thing that looks like a TIE fighter up here, and it says start a new sharing session, and it gives me another code. Now this one does change when you do different experiments on different days. And so this one is not like the license key. What you need to do is type that code into the box that I told you to open and wait. So you would type I'm on my iPad, BHG, the number 3, and then IW. We actually asked the software guys, make this one a little simpler, especially for people that are doing this on like a phone or doing it on like did I do it wrong? Oh, I forgot the H. I'm talking. I tend to, when I talk, I tend to forget what I'm doing. Let's see here. I forgot, that's why. All right, BHG, the number 3, and then IW. And so what should happen is you should end up with, there's my iPad. I'm going to turn that red thing off. You should end up with %T and wavelength. And so I'm hoping that that's happening for you guys.
I got it. I can see your %T versus wavelength.
Okay. We're back to the lab now. Okay. So, and if you have trouble, just, you know, chat with Melissa and she'll help you figure it out. But I'm back to the lab now. Okay. And here's what's going to happen. I'm the student and I need to figure out what wavelength to use for the rest of the experiment. So you gave them this stock solution. They're going to do pretty much the same thing that we did the day before, except in %T. So they might come in and hit collect, and it's going to tell them to put a blank in. Since mine has been on a really long time, when it gives me the option, I'm going to skip the warm up. Your students would not do that. They would, you know, the first time through, they should go through the 90-second warm up, but I'm not going to do that. Okay, and so it's recalibrating now. Now remember, this is the next day, so you have to kind of play a little bit in your mind here. Okay, and so it's ready, and so I tap OK, and let me so what the student would do is they would take some of the solution, put it in a cuvette, put it in there, and start collecting data. Sorry, you'll get it here in a second. Now on your end, if it says join new experiment, tap on that. So I noticed that on my iPad, it just came up and said join new experiment. That was because I jumped the gun there a little bit. Okay, so tap on join new experiment and you'll get the data. Isn't that crazy? Okay. It's like I did a workshop with teachers in Belgium yesterday, and it was like 5,000 miles away. And, you know, so what's the point here? I'm going to stop collecting data. On your end, it probably says collecting. Okay. And so I'm going to, on my Labquest, I'm going to tap on the little red square stop sign. Remember now, this is the student in your classroom and presumably using a Labquest, and their job is to find lambda max, right? Or in this case, because it's %T, lambda min. So what you would do is tap on your screen, okay? So notice that I'm doing it on my Labquest. Nothing's happening on your end. You got to do it yourself, okay? The way data sharing works is that once the student gets the data, they're on their own. Okay, so they got to do the whole analysis themselves. So this part of the experiment was for them to determine what value are we going to set the spectrometer to in order to do the second part of the experiment? Let me remind you what that is. The second part of the experiment is for them to measure the percent T of different dilutions of the standard. Okay, and so in the pre-lab, they do the M1, V1, M2, V2 calculations. I did that for you on the spreadsheet, so we wouldn't fiddle around with that today. So it's on the spreadsheet. You know, you probably don't want to share that with your students, but that's what we're going to need in order to do the next part of the experiment. So one note, if you want to save this right now on your end, tap where it says untitled and save it, because I'm going to switch modes to do the data that the Beers, basically the Beers law plot. It's kind of the logarithm of the Beers law plot, but that's what I'm going to do. So if you want to save this, I'm going to start a new experiment like I did a minute ago, and you're going to get a thing that says join experiment. So if you want this, this is the time to save it. Just like on any device, you just go to save and put it somewhere where you can find it later. Maybe call it, you know, sports drink experiment 1 or something like that. So so the student has determined now what wavelength they need to use to do the experiment. Okay, and so now the next step is to collect the percent T's of all these stock solutions. Okay, that they're told pardon me, all these dilutions that they were told to make. Now, you could do this next part of the experiment, you could do it right here. You could make all your dilutions, put them in there, and just hit the collect key and get the percent T, just like we did just now for this solution. We could just do it right now. What happens if you do that is you end up with a table with a bunch of numbers in it that you're going to have to later go back and graph. If you remember the experiment, what you're going to have to do is you're going to have to, at some point, and if you haven't done the experiment, I gave it to you. Let me show you. And what the students are going to be asked to do is make a series of graphs. Right there. So they're going to make a series of graphs. And then, you know, if you just write the percent T and the concentrations down, you're going to have to enter it into Excel. You could enter it into Logger Pro or into Graphical Analysis manually. But hey, Noose, wouldn't it be nice if we could do all this at once and not have to enter extra data in? Absolutely. That's the plan. So here's what you and I are going to do right now. I'm gonna be the student sharing with his lab partners. Okay, so what I'm going to do now is I know that I want to measure this percent transmittance at this wavelength that I selected on my Labquest. So what I'm going to do is I'm going to change modes, and so do that. You go back to the meter window. On the top right, you'll see it says full spectrum. Well, I want to know the absorbances at specific concentrations and at a specific wavelength. So I'm going to tap there, and I'm going to change the mode. Instead of full spectrum, I'm going to make this an events with entry, where the event will be the concentration. So if you've done any of our Beers law experiments from any of our other books, then you've probably done this before. Oops. I have fat fingers and that sometimes dry out, so I'm using one of these styluses because it just helps me, you know, poke better. And so our concentration is moles per liter. Now, don't panic. You guys are going to get all this. Where's my other slide? There it is. Oops. It's kind of the cool part of all this. So there we go. Ready to roll. Let me tap OK. It's going to come up and say, hey, you got data in here. Do you care about it? I don't, but you know, the students might want to save it at this point. But for our workshop, I'm not going to save it. I'm just going to discard it. And so notice the screen, 632 nanometers. That was the lambda max or lambda min that I picked. And so I'm ready to go. But what I need the dilute solution. So let's get those made up real quick. So let me go back to my spreadsheet. And so there's a fast way to do this that works okay for this lab. You might also use pipettes, but I'm going to do it the fast way. Solution number 1 is the stock solution. Let me turn that stir up. So, I'll get the camera up here so you guys can see what I'm doing here. So solution number one, that's the stock solution. Solution number two, well, I'm not gonna do them all because that's a lot. So I'm gonna do number two. I need 8 milliliters of stock and 2 milliliters of water. And don't yell at me if I'm off a little bit here, folks. I want to get this all done so that you guys can get a full experience here. So I'm not going to be super hygienic. I'm not going to rinse everything every time. We're going to do, that was number two. We're going to do number four. That's 4 milliliters of stock. A pipette would probably be a little better. And then top that up with water. The students are going to need about 3 milliliters, a little bit less. I think the cuvettes are 3.5 milliliters, but they're going to need about that much for each run. And so, 10 milliliters gives them a little bit of extra so they can mess up. So that's 3 milliliters, a little more than 3 milliliters. Let me see if I can squirt out some of that. There we go. And then top that up. That's test tube, that's 5. The more of these you do, that I would assume the better your plot will be. But for the workshop, I didn't want to belabor this too much. Number 7, just 1 milliliter. Let me get some stock. I just need 1 milliliter. And top that up. I was surprised one year I was going through the stock room or the storage room, and we had these little 10 milliliter volumetric flasks. They're the cutest looking little things you ever wanted to see. And then our unknown, the last one will of course be the sports drink. So we're pretty close to ready. And so let me slide that kind of out of the way, and we'll start collecting data. So I'm going to tap on collect. Okay. Now this time, let me get the Labquest screen up so you guys can see what I'm doing. And I'm also going to start on my copy. I'm the teacher, remember. On my copy, I'm going to start a new experiment. Yes, that's right. And so here's where, if you guys want to save that full spectrum that I did, make sure you save it, because otherwise, if you want, because you're going to lose it here in a second. I'm going to start a new session. So I'm going to go and reconnect to my Labquest. And when I do that, so look on your screen, it probably says join new experiment. Okay, so you probably want to do that. And then when you do that, you'll notice that this time your screen says the same thing as mine. It says the %T versus the concentration, which is what we want. Okay, so we're all set. Let's get all those values. The only other thing I'm going to need is I'm going to need to see the concentrations. I probably should have thought of a smart way to put that in a different window, but that's all right. So this is actually my stock solution. So that's number 1. You remember we've been fiddling with that, so that'll save a second. Put that in there. On the Labquest, what you want to do is observe the meter up here at the top and make sure that that value stabilizes. When it does, you tap keep, and it's going to say, okay, what's the concentration? And that's the thing that I said I should have put somewhere in a different window. So that one is 7.15 times 10 to the minus 6. So let me put that in. 7.15, kind of like the old style calculator, E, and then minus, where's 6? Like that. So the old TI calculators and stuff like that. So there we go. Now you should have a point on your graph. Okay. Now, if you don't see it right away, or if you would like to see it a little bit more clearly, you can open a data table. And so the way you would do that is up here in the top right on graphical analysis, there's this view options, this box of boxes. Tap on that, and then turn on the switch for data table. I'm using my dry thumb and it's not working. There we go. And then you should open up a data table. I'm going to get my iPad out of the way so that we can do more. So I did the first one. Let me bang through here on the rest of them so that we can move on. So I'm going to dump the cuvette out. I'm going to get test tube number 2. Let me get my barrel pipette. I'm going to squeeze it, rinse. All right, we'll call that good. Some of you will excuse me for kind of going fast, but I don't want to use up all the time. Let me get that in there. I'm looking at for number 2, I'm looking at the % value up here on my LabQuest. Once it stops changing, I'm tapping keep. And that one, number 2, is 5.72 times 10 to the minus 6. You should have 2 points on your graph at this point. Let's dump that out and get test tube number, which one's the next one? 4. Rinse my barrel pipette, rinse my cuvette a little bit. Light path on the GoDirect SpectroVis is below halfway. So as long as you've got halfway full or more solution, then you should be good. LabQuest looks like it's stabilized at 44.4. Keep that value. So test tube, which one did I just do? I did test tube number 4. So that's 2.86 times 10 to the minus 6. And one more, right? Oh, no, I got to do number 5. Okay, 2 more. Okay, let me grab some number 5 and rinse my barrel pipette and rinse my cuvette. I'll get some fresh 5. So that's why, the 10 milliliters is a good volume because, if you mess up or something, you've still got enough that you can go back and without having to remake it. So that one, 53.5, looks like it's pretty stable. Tap keep. Number 5 is 2.15 times 10 to the minus 6. Now remember, the kids did these concentrations in the pre-lab. So they got a chance to use the dilution equation. Not always my favorite equation. For 1-to-1 mole ratio, it's fine, but sometimes they want to use that dilution equation for everything, and it's like, hey, there's certain times when that doesn't apply. So let's see, do the last one here. We're almost done. Okay, so number 7. You can kind of see the graph appearing, I think, on your end.
I can see it. I'm getting all your data points. It's
Excellent.
looking good. It's looking pretty solid data.
Pretty like what we would expect. Yeah,
yes,
we hope
yeah.
anyway.
Yeah, exactly.
Now your students wouldn't necessarily expect this, but if you've done this before, this %T should not come out linear. So that one, that's that one. Why is that? Oh yeah, it's high. It's very high transmittance because it's a very color. If you look at the test tube, it's pretty low concentration. So let's grab that one, and then we're going to be done. That was test tube number 7, 7.15 times 10 to the minus 7. Yeah, that one is lower concentration. And we're going to be done here, and we can do some analysis. We got 10 minutes. We can be able to get them all done. Okay, so I am done. Okay, now kids would do a couple more, but this is good. So I'm going to stop collecting data. Okay, and now what the students are supposed to do, if you go back to the lab sheets, is they're supposed to look at graphs of all these other things. Once again, it's your call. What is the best way to do this, right? Well, you can do all of this on a LabQuest, but since we all have it on our graphical analysis, why don't we do it all in graphical analysis? The idea here is, if you read the directions in the lab, it says, find a plot that's linear that has a positive slope. And it's, so what we can do in graphical analysis, bottom left corner, let's test and see if this is linear. Bottom left corner, there's a little graph tools icon. Okay, tap on that, and then choose apply curve fit. And let's see how linear it is. Okay, now there's other fits, but you know, spoiler alert, you know, the thing is kind of logarithmic, but we're not going to mess with it. We're the student. We're trying to see if we can make this linear. So we go ahead and apply the linear fit. Yeah, it's got, you know, it's sort of kind of, you know, the correlation coefficient is the teller of that. So what we need to do is try some other options. Like, let's change %t to t. On the top right corner, if you haven't already done it, turn on the data table. And let's go ahead and calculate T from %T, for transmittance from %transmittance. So what you want to do, by the way, if this bothers you over here, look at my concentrations. They're all 0? No, it's significant figures. Tap on the 3 dots next to concentration, go to column options, and you know, it's showing decimal places. Change that to scientific notation. Okay, and it should look a lot better. Okay. But anyway, getting back to this, let's do a calculated column, 3 dots next to the %t, and let's add a calculated column. Sort of like you would do on Excel or Sheets or something. And what we need to do is we need to decide, how are we going to change %t to t? For some kids, that might be a little bit of a challenge. Like, how do I change % back to not %? Okay, well, we need to divide by 100 or multiply by 0.01 or something like that. This equation, the first one up here, that one would probably do it. All I need to do is take this should say %transmittance. I just got it from the Labquest. Change this multiplying factor to 0.01. Don't change the exponent that you're raising it to, because there's lots of different ways that you can put in expressions. And let's take a look at that. If yours didn't automatically switch to T, tap on the Y-axis label and you can turn on and off what you want plotted. Mine did automatically change, but yours may not have, sometimes depending on where you are and what you're doing. Hey, Noose, where's the numbers? Double click the graph, or down here, there's a magnifying glass. You can use that too, and that'll zoom it up. Now, we just multiplied by a number, so that didn't change the plot. At least didn't change the linearity any. But if you want, go to the graph tools icon and choose apply curve fit, the linear fit. You're going to see it's pretty similar. Let's try a couple other ones. Like if we go to the lab, we have to do 1/t. Well, tell you what, because time is running short, let's jump to the finale. I'll leave it to you guys to figure out how to do these. But let's take the logarithm, the negative logarithm of t. So at least you can see that one. That is, you know, the finale in this. And with less than 10 minutes, I want to make sure, give a little time for talk. So I'm going to tap on the 3 dots next to T. I'm going to create a calculated column. This one will be, it'll be the minus log of T. And let's go explore how to put that into an expression. So let's go down here and click on insert expression. There's a natural log that says A times log of T. So that one will work pretty well. We just need to make A minus 1. One thing you want to make sure that what shows up under column X is actually what you want, because you can set up a calculated column based on any other column, and what shows up here might not be what you want. So you might have to, you know, triple check. Sometimes I've you know, the one before this one is the plus log, and I've done that before, and then I by accident chose that one to do the minus log. I end up with a log, which is, you know, kind of weird. But anyway, this one looks okay. Let's tap on apply. Ooh, baby. Let's see how linear that came out to be. So by the way, if you didn't show up on yours, tap the Y-axis label and choose it. You might turn off the ones you don't want to see. And so we'll do a linear curve fit. And all right, this was me, like making up these wacky little solutions here at my home lab. Let's see. Let's see what the correlation coefficient is. Not bad, right? Definitely more linear than anything else. So what have we done here? Well, what we've done is we've set up the standard curve. So wait a minute, Noose, the point of the lab was to find the concentration of the food dye in the sports drink. Oh yeah, let's go back to the Labquest. There's the Labquest. I'm going to go back to the meter window, okay, and I'm going to take a sample of the sports drink. So what's nice about this, yeah, the lab the College Board in our lab talks about blue sports drink, but you could do this with any other sport. You could have different groups doing different colors. All right, let's check out this. Whoops, sorry, let me get the camera up here so you can see what I'm doing. So let me get some of this Powerade here. I mean, one bottle of this would probably be like, depending on how big your AP class is, definitely going to be enough for the whole class, but might be enough for multiple years. I don't know how scungy it might get over time. All right, let me stick it in here. This meter is still live. It's still working. So my Powerade blue sports drink transmits at 39, looks like right around 39.0, kind of a little flopping around there. And so if we go back to our graph, now this is where your students got to figure out how to do this, right? We're reading %T, but we're plotting minus log. So they're going to have to, I mean, the easiest way to do this is you get out your calculator and you figure out the minus log of that, right? So you get your calculator out and you go minus log of, and then of course T, so it's got to be 0.393 is what I'm showing on my screen right now. And so that value is 0.406, right? 0.4 to 3 significant figures. So go back to your graph. The right way to calculate the concentration would be to use the regression expression, right? What we just calculated was y, x is the concentration, put the slope is whatever this is, 120,000, and the y-intercept. Now the cheater's way, I would not show the students, but they might find it, is under the graph tools, there's an option called interpolate. And what this will do is when you tap on the graph, when you slide around, you could find that value that was on the calculator, 0.406. Interestingly, and Melissa, we need to talk to the programmers. It's not doing it in scientific notation, so it's showing that as 0.0000000.
I know. I was just noticing that when I was playing with it. I was like, screenshot, send it to software.
Yeah, we're going to send this to software guys and say, hey, we just did a popular experiment and it's not, the interpolation option isn't showing it. So for now, you would have to calculate it from the regression equation. I killed the whole hour. Does anyone have any burning questions that they just need answered right now that we can help with? I'm going to throw another screen up here from the slide deck too. Any questions? We are available to you most days. And so there's a couple of ways to get in contact with us. Chemistry@vernier.com is going to come to Melissa, Elaine, or me, okay, just the three of us. So that's probably the easiest way to contact us. You can always call and ask for one of us. Just say, I need to talk to someone in chemistry. And then we have a chat feature on our website that you can use. A couple of other things in this last couple seconds. GA Pro has a lot of stuff in it that might be of interest to you that you might want to explore. And we have some videos on this in various places that you can look at. So for example, there's a lot of built-in data sets and videos. Yes, GA Pro allows you to look at videos. So if you tap on See Experiments, that you can filter them by content. So you can go and say, I want to just look at chemistry, and Melissa has a really nice one here for the crystal violet rate determination. So you can pull this down. And what she did was she did it on a colorimeter, which might be, you know, you can do this on a spectrometer, but it's more challenging to get the data into graphical analysis. But what she did was not only did she create a video so you can see how the experiment is done, but she also collected data simultaneously. And using this arrow at the top here that says enable replay, you can actually synchronize this so that actually this one is synchronized so that if you play it from here, it will synchronize the data with the video. There's a bunch of these already in graphical analysis, but you can also do your own. So under the view options menu, you can add your own video. So if you've got a set of data that you've collected and you like to add some video to it, you can absolutely do that. So there's a bunch that are built in, or, you know, you could have the kids do a titration, and then you could have them, why is that not coming in? Oh, let's check here. So you could have the students do a titration. They could take a video of themselves doing it, and you could insert that into I don't have a titration video, so this is not going to be really pretty, but I didn't plan for that. But yeah, you could go and have a video. Here's a drop counter calibration with it. And so you could have a video with this. So your students could do that, right? They could synchronize video with their data. A couple of other things I put on the slide deck, because since we are absolutely out of time, there is a feature comparison sheet that Melissa created, so you can compare what's already in free, what's already in pro, and down at the bottom of the right talks about future things like striking through data and data marking, which are features that are coming in the future. I think I exceeded my time, but Melissa or Angie, is there anything that needs to be talked about?
No, I think you covered it all.
Okay. Well, folks, thank you so much for spending a little time with us today. If there's anything that we can do, please don't hesitate to contact us and let us know how we can help. Okay?
Yeah. Thanks, everyone.